Welcome to our comprehensive guide on data communication and networking, designed especially for NIOS Class 12 computer science students. In this lesson, we'll explore how data travels between devices, the essential elements that make communication possible, and the networks that connect our digital world. Whether you're curious about how your messages reach friends or how the internet functions globally, this video will break down the concepts into easy-to-understand segments. Let's begin by understanding what data communication really means and why it's so crucial in today's technology-driven society. Data communication is the process of exchanging information between two devices using a transmission medium. Imagine sending a message from your computer to a friend's phone. Data communication makes this possible. For effective communication, several key elements must be present. A sender, the device that initiates the message. A receiver, the device that gets the message itself, the information being sent. A transmission medium, like cables or wireless signals. And a protocol, the rules that guide the exchange. Each of these elements plays a vital role in ensuring your data reaches its destination accurately and on time. Let's dive deeper into the 5 essential elements of data communication. The sender is the device that creates and sends the message, while the receiver is the device that accepts it. The message is the actual data or information being transmitted. The transmission medium is the physical path, like cables or radio waves, that carries the message. Finally, the protocol is a set of rules that ensures the message is sent and received correctly. Together, these elements guarantee that data is delivered accurately, securely, and promptly, forming the backbone of all digital communication. Data communication to be truly effective, it must meet 3 important characteristics: delivery, accuracy, and timeliness. Delivery means the data must reach the correct destination. Accuracy ensures that the data arrives without errors, and timeliness means the information is delivered when it's needed, not too late or too early. These characteristics are essential for everything from sending emails to streaming videos, ensuring that our digital experiences are smooth and reliable. Data can be communicated in different ways, known as modes of communication. There are 3 main modes: simplex, half-duplex, and full duplex. Simplex mode allows data to travel in only one direction, like a keyboard sending input to a computer. Half-duplex allows data to flow in both directions, but only one at a time. Think of a walkie-talkie. Full duplex enables data to move in both directions simultaneously, just like a telephone conversation. Understanding these modes helps us choose the right method for different communication needs. Simplex communication is the most basic mode, where data flows in a single direction only. A classic example is a keyboard sending keystrokes to a computer. The computer receives the input, but cannot send data back to the keyboard. This mode is simple and effective for scenarios where feedback isn't necessary. However, its limitation is clear. Only one device can transmit, and the other can only receive. Half-duplex communication, both devices can send and receive data, but not at the same time. Imagine using a walkie-talkie. You press a button to talk and release it to listen. This mode is useful in situations where two-way communication is needed, but simultaneous transmission isn't required. It's a practical solution for many real-world applications, balancing efficiency and simplicity. Full duplex communication allows data to flow in both directions at the same time. This is how telephones work. Both people can speak and listen simultaneously. Full duplex systems are more complex, but provide a seamless communication experience, making them ideal for conversations, video calls, and other interactive applications. Networks can be classified based on their geographical coverage. The first type is LAN, or local area network. LANs cover small areas like a single building, school, or office. They are known for high speed and low cost, making them perfect for connecting computers within a limited space. LANs are commonly used in homes, schools, and businesses to share resources and information efficiently. Next, we have MAN, or Metropolitan Area Network. MANs cover larger areas than LANs, such as a city or a large campus. They connect multiple LANs within a metropolitan region, providing efficient communication across different locations. MANs are often used by organizations with offices spread across a city, enabling seamless data sharing and collaboration. WAN, or Wide Area Network, covers the largest geographical areas, such as countries or even continents. The Internet is the most well-known example of a WAN. WANs connect multiple LANs and MANs, allowing data to travel long distances. While WANs are slower and more expensive than LANs, they are essential for global communication and information sharing. Network topology refers to how devices are physically or logically arranged in a network. The layout of a network affects its performance, reliability, and scalability. There are several common topologies, each with its own advantages and disadvantages. Let's explore the main types: bus, star, ring, and mesh topologies to see how they shape the way data travels within a network. Bus topology uses a single backbone cable to connect all devices in the network. It's easy to install and cost-effective, making it popular for small networks. However, if the main cable fails, the entire network is affected. Bus topology is simple but not very reliable for larger or more critical networks. In star topology, all devices are connected to a central hub or switch. This setup is highly reliable because if one cable fails, only the connected device is affected, not the entire network. Star topology is widely used in modern networks due to its reliability and ease of troubleshooting. Ring topology connects devices in a circular fashion, where data travels in one direction around the ring. If any single device or connection fails, the entire network can be disrupted. While ring topology is simple and orderly, its main drawback is vulnerability to failures. Mesh topology is the most robust, connecting every device to every other device in the network. This setup provides high reliability because even if one connection fails, data can take another path. However, mesh topology is expensive and complex to install, making it suitable for critical networks where reliability is a top priority. Transmission media are the physical paths that carry data from one device to another. They can be classified as guided, wired, or unguided, wireless. The choice of transmission media affects the speed, security, and reliability of data communication. Let's look at the main types of guided and unguided media used in networks today. Twisted pair cables are the most common type of guided media, especially in LANs. They consist of pairs of wires twisted together, which helps reduce interference. Twisted pair cables are inexpensive and easy to install, making them a popular choice for connecting computers and devices within buildings. Coaxial cables are shielded cables often used in cable TV systems and older computer networks. Their shielding protects against interference, making them suitable for environments with electrical noise. Coaxial cables are more expensive than twisted pair, but offer better performance in certain scenarios. Fiber optic cables use light signals to transmit data at extremely high speeds over long distances. They offer the fastest data transmission and are highly secure, making them ideal for backbone networks and critical applications. Although more expensive, fiber optics are the gold standard for modern high-speed communication. Radio waves are a type of unguided, or wireless, transmission media. They can travel long distances and are omnidirectional, meaning they spread in all directions. Radio waves are commonly used for broadcasting, Wi-Fi, and mobile communication, making wireless connectivity possible in many environments. Microwaves are another form of wireless transmission, used for point-to-point communication. They require a clear line of sight between the transmitter and receiver, making them ideal for satellite systems and long-distance telephone networks. Microwaves are fast and efficient, but obstacles can disrupt the signal. Infrared transmission is used for short-distance communication, such as remote controls and some wireless devices. Infrared signals cannot pass through walls, making them suitable for confined spaces. While not as versatile as radio waves or microwaves, infrared is reliable for specific applications. Networking devices are the hardware components that make data communication possible. Each device has a specific role, from connecting computers to managing data flow. Understanding these devices helps us build efficient and secure networks. Let's look at the main devices: hub, switch, router, modem, repeater, gateway, and bridge. Hub is a simple networking device that broadcasts data to all devices connected to it. While easy to use, hubs are inefficient and insecure because every device receives all the data, regardless of the intended recipient. Hubs are rarely used in modern networks, having been replaced by more advanced devices. Switches are smarter than hubs. They send data only to the intended device, using MAC addresses to identify recipients. This makes switches faster and more secure, reducing unnecessary traffic and improving network performance. Switches are the standard choice for most modern networks. Routers connect multiple networks together, such as a home network to the internet. They perform routing, determining the best path for data to travel. Routers are essential for internet connectivity and play a key role in managing traffic between different networks. Modem converts digital signals from computers into analog signals for transmission over telephone lines, and vice versa. This device is necessary for connecting to the internet using traditional phone lines. Modems bridge the gap between digital devices and analog communication systems. Repeaters are used to boost weak signals, allowing data to travel longer distances without loss of quality. They are especially useful in large networks where signals may weaken over long cables. By amplifying the signal, repeaters help maintain reliable communication across extended areas. Gateways connect different types of networks and act as protocol converters. They enable communication between networks that use different technologies or standards. Gateways are essential for integrating diverse systems and ensuring smooth data exchange across platforms. A bridge connects two LAN segments and filters traffic between them. By dividing a network into segments, bridges help reduce congestion and improve performance. They are useful for managing large networks and ensuring efficient data flow. Protocols are sets of rules that govern how data is exchanged between devices. Without protocols, devices wouldn't understand each other, leading to communication breakdowns. Protocols ensure that data is sent, received, and interpreted correctly, forming the foundation of all digital communication. TCP/IP, or Transmission Control Protocol Internet Protocol, is the backbone of the Internet. It defines how data is packaged, addressed, transmitted, and received across networks. TCP/IP ensures reliable communication between devices worldwide, making global connectivity possible. HTTP, or Hypertext Transfer Protocol, is used to transfer web pages over the Internet. HTTPS is the secure version, encrypting data for safe browsing. These protocols make it possible to access websites and ensure that sensitive information, like passwords, remains protected during transmission. FTP, or File Transfer Protocol, is used to upload and download files between computers over a network. It's commonly used by web developers and administrators to manage website files. FTP makes file sharing and management efficient and straightforward. Email relies on several protocols to function smoothly. SMTP, Simple Mail Transfer Protocol, is used to send emails, while POP, Post Office Protocol, and IMAP, Internet Message Access Protocol, are used to receive them. These protocols ensure that your emails are delivered and accessed reliably, no matter where you are. Telnet and SSH are protocols that allow users to log into remote computers over a network. Telnet provides basic remote access, while SSH, Secure Shell, adds encryption for secure connections. These protocols are essential for managing servers and remote systems safely. The Internet offers a wide range of services that have transformed how we communicate, work, and access information. From browsing the World Wide Web to sending emails, chatting in real time, and participating in video conferences, the Internet connects people and resources globally. Let's explore some of its most important services. The World Wide Web is a collection of interlinked web pages accessible through browsers. It allows users to access information, multimedia, and services from anywhere in the world. The WWW has revolutionized how we learn, shop, and interact online. Email is one of the most widely used Internet services, enabling fast and reliable electronic mail exchange. It allows people to communicate instantly across the globe, making personal and professional communication more efficient than ever before. Chat and messaging services provide real-time text communication between users. Whether it's instant messaging apps or chat rooms, these services make it easy to stay connected with friends, family, and colleagues, no matter where they are. Video conferencing enables real-time audio and video meetings over the Internet. It's widely used for business meetings, online classes, and virtual gatherings, making face-to-face communication possible even when people are far apart. FTP services allow users to upload and download files over the Internet. This is essential for sharing large files, updating websites, and managing data remotely. FTP makes file transfer simple and efficient for both individuals and organizations. Search engines like Google and Yahoo are powerful tools for finding information on the Internet. They index billions of web pages, making it easy to retrieve relevant data in seconds. Search engines are essential for research, learning, and staying informed. Network security involves policies and practices designed to protect networks from threats. With increasing cyberattacks, securing data and systems is more important than ever. Let's explore the types of security threats and the measures we can take to safeguard our digital world. Malware includes viruses, worms, and Trojan horses, programs designed to harm or exploit computers. Viruses attach themselves to files, worms spread through networks, and Trojans disguise themselves as legitimate software. These threats can damage data, steal information, and disrupt operations. Beyond malware, there are other threats like spyware, adware, phishing, hacking, identity theft, and ransomware. Spyware secretly collects user data. Adware displays unwanted ads, phishing tricks users into revealing personal information, and ransomware locks files for ransom. Hacking and identity theft involve unauthorized access and data theft. To protect against threats, we use antivirus software to detect and remove malware, and firewalls to filter network traffic. These tools are essential for keeping devices and data safe from unauthorized access and attacks. Encryption converts data into unreadable form, ensuring that only authorized users can access it. Authentication verifies the identity of users through passwords, biometrics, or one-time passwords. These measures are critical for protecting sensitive information and maintaining privacy. Additional security measures include using strong passwords, regular data backups, securing Wi-Fi networks with WPA2, WPA3, and keeping software updated. These practices help prevent data loss, unauthorized access, and vulnerabilities, ensuring a safer digital environment for everyone. This lesson, we covered the fundamentals of data communication and networking, including the elements of communication, network types, topologies, transmission media, devices, protocols, internet services, and security. Understanding these concepts is essential for navigating and securing our increasingly connected world. Keep exploring and stay curious about the technology that powers our daily lives.